Okay, guys, let's talk about finding slope using a graph. So we're always going to first look at up and down. We call that rise. We're going to be looking at up and down, and then we're going to be looking left and right. You're always going to start on the left-hand side of your graph, and you're going to count either up or down first, and then you're going to move right. So let's see how this works. And I just wanted to show you this page because it says choose 2 points. They're clean grid marks. So let's see what that looks like. And fractions must be reduced. So if you have a hard time reducing fractions, we're going to show you how to use Desmos to reduce those fractions. Okay, so I have a graph. It doesn't have any solid points on it anywhere. It doesn't have anything, say, like this one and this one, but these are clean grid lines. So we're going to start with this one. We're always going to start on the left, which is over here. The right is this way. Okay, and we're going to count 1, 2, 3 up. Once we get here, we're going to move over. So this is going to be my numerator. And now we're going to find the denominator. 1, 2, 3, 4, 5, 6. 3 over 6 is what I found. Can that fraction be reduced? Oh, let's use Desmos to find out. I have 3 divided by 6. I'm going to convert that into the simplest fraction I can find, and it turns out that that is equal to 1 over 2. So the slope of this line, which is always written as m, is equal to 1 over 2. And you can see that if you choose any other 2 points on this graph, let's say I pick this one and this one, it's going to give you that same ratio no matter what points you pick. You can either go up or down. Well, I need to go up here, up 1 on the top, and I'm going to move 1, 2 over. My slope there is also 1 over 2. What about between here and here? I go 1 up, I go 2 over. Well, it's also 1 over 2. And here's another one where we are going to have to plot the points ourselves to find the slope. So find the slope using this graph. This looks like a nice clean point, and this looks like a nice clean point. Let's try these. What I mean by clean points is that they cross. They're on a place where the grid marks cross like this, very neatly. I can see here. Let's start this one up. Okay, let's clean this up and try this one again. So I'm looking at a place where it crosses the graph neatly. This graph is not fantastic. But you want somewhere where you're looking at grid marks, right, that you can see exactly the number of squares in between. So 1, 2, 3, 4, 5. I went 5 down, so this is negative, and I went 1 to the right, so my run is 1. And this can be reduced to negative 5. So this one has a slope of negative 5. Now, if I go to the next point, that slope should be continuous anywhere along the graph. 1, 2, 3, 4, 5 down, and 1 over. Again, slope is equal to negative 5. What if I go from this high point up here down to this point here? Will the ratio remain the same? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 down, 1, 2 over, so it's negative 10 over 2. And again, if I'm struggling with that fraction, I can use Desmos and say, what is negative 10 divided by 2? And it's going to tell me that it is negative 5. Okay, we're going to look at 2 special cases, a horizontal line and a vertical line. And horizontal lines can always be remembered by the acronym HOI, which means it is a horizontal line. It looks like the horizon, right? This goes this way. It has a slope of 0, and the equation always looks like y equals a number. I've also heard that as it crosses the y-axis, and you can see here that it is crossing the y-axis. And this line is at 1, 2. It's at y equals 2. We've gone 0 over and 0 up, but at the y-axis, y is equal to 2. And anywhere I go, 1 over 2 up, 2 over 2 up, 3 over 2 up. Anywhere I go, y is equal to 2. So that is the equation of this line. And the slope of this horizontal line is always going to be equal to 0. So if I'm given a graph that looks like this, and you see a horizontal line and it's asking you for the slope is always going to be 0. Now let's look at its alternate, which is a vertical line. You can always think of a vertical line as with the acronym VUX. It's a vertical line with an undefined slope. And it always looks like x equals a number is the equation of the line, or you can think of it as crossing the x-axis. And here's the x-axis, and we can see that this line crosses the x-axis. So let's erase this. And if we are asked to find the slope of this line, it's going to be m is undefined. M equals undefined. And here we are going, we go 2 over and 0 up, we go 2 over and -1 down, we go 2 over and -2 down. Everywhere that we go, we're going 2 over. And so therefore, x is equal to 2 is the equation of this line. Okay, hopefully that helped a little bit. You can always remember those special circumstances. And so say that you're given a graph like this, and you are given a line that looks like this, and you're asked to provide the slope of this line, you're going to say m is undefined. Thanks for watching.